If you really want to understand the true scale of global energy infrastructure right now, you can't just look at a spreadsheet.
Right, absolutely not.
You have to look at a single week, specifically mid-June 2026, where a 1,000-ton, 31-meter-wide steel dome is just being hoisted into the air to cap a nuclear reactor.
Yeah, it's a piece of engineering so massive it requires, some of the largest cranes on Earth. And yet for them, it's basically just another Tuesday.
It really is. Welcome to the Deep Dive, everyone. We've got a really specific mission today. We are unpacking an institutional-grade intelligence brief.
Dated exactly June 24th, 2026.
Exactly. And this is a strictly factual, site-by-site status update on China's nuclear power construction program. Our goal is to help you comprehend the sheer velocity of this rollout.
Yeah, because we are looking at an industrial mobilization that, honestly, it kind of shatters our standard expectations of how infrastructure gets built.
Totally. So to set the baseline for you, as of mid-June 2026, China currently operates approximately 62 nuclear units.
Which is huge.
Right. That equates to around 62 gigawatts electrical, or GWe, of total capacity, making it the second largest operating fleet in the world, right behind the United States.
But, the metric that really changes the global energy map is what's happening in the pipeline.
The new builds?
Exactly. They continue to lead the world in new build by a massive margin. The brief says they have over 39 additional units currently under construction.
Wow. 39.
Yeah. That is an astonishing 37.3 gigawatts of new capacity being built simultaneously. And just to be clear on our approach today, we are sticking strictly to the facts and figures in this intelligence brief.
Right. No speculation, just an unvarnished look at the mechanics of this.
Exactly.
And before we get into all the heavy machinery, a vital disclaimer for you. This is an informational update only. It is compiled from this specific briefing and does absolutely not constitute investment advice.
Yeah, we are not telling you what this means for, uranium markets or anything.
Nope. We're simply decoding the reality on the ground.
Which, honestly, is complex enough on its own.
It really is. Okay, so let's unpack this. To understand how you even manage 39 simultaneous nuclear builds, without the supply chain just completely collapsing, we have to look at the macro-level policy.
Right, the policy engine driving the whole thing.
Yeah. The brief highlights the 15th five-year plan, which was approved in March 2026. Their target is 110 gigawatts of nuclear capacity by 2030.
And that is just the medium-term milestone. The brief actually cites a wider long-term policy aspiration to hit 200 gigawatts by 2035.
200 gigawatts, that's wild.
It is. And to put that into perspective for you, hitting that 2035 target would bump nuclear from contributing about 4.5% of their national power generation today up to around 10%.
Wow. But, I look at a number like 39 units under construction, and I just immediately wonder how that doesn't devolve into total logistical chaos.
Right. It seems impossible.
But the answer seems to be in what the brief calls batch approvals. Like in April 2025, the State Council approved a massive batch of 10 new reactors across 5 different sites.
Yeah, and we should name those. It was Fangchenggang Phase 3, Haiyang Phase 3, Sanmen Phase 3, Taishan Phase 2, and Xiapu Phase 1.
Right, and this single batch represented an investment of roughly 200 billion yuan, which is about 27 billion US dollars.
That's a staggering amount of capital.
Yeah, but the really wild detail here is that April 2025 marked the 4th consecutive year of 10 or more reactor approvals.
And that consecutive nature, that's really the linchpin of the entire strategy. That's what makes this an unprecedented pace, like the brief says.
Okay, let me test an analogy on you. Because usually when we think about building a nuclear power plant, we treat it like building, a bespoke cathedral.
Like a unique generational mega project.
Exactly. But looking at these batch approvals, it feels much more like manufacturing airplanes, like an assembly line.
I think the airplane analogy hits it perfectly, because think about it. If you're a company that forges the spiralized heavy steel components for a reactor core, you can't scale up your factories if you only get one reactor order every 5 years.
Right, the financial risk is just way too high.
Exactly. So what these batch approvals do, 10 units a year, 4 years in a row, is provide absolute regulatory and financial certainty to the supply chain.
So it tells the concrete suppliers and the steel forgers that there's a continuous pipeline.
Yes. It creates a staggered ecosystem. As one reactor transitions out of the messy civil construction phase, the team that specializes in pouring concrete can immediately move to the next site that was just approved.
Which perfectly sets up the mechanical pipeline for the 7 separate reactors that are scheduled to be commissioned in 2026 alone.
Exactly.
Which actually brings us directly to the reality on the ground during the specific week of June 15 through June 21, 2026.
Right, the weekly update.
Yeah. The brief tracks 4 major construction milestones that happen in just those 7 days. Let's start with Lianjiang Unit 1. This is where we see that massive outer containment dome I mentioned at the start.
The 1,000-ton dome.
Yes. The brief gives the exact specs. It's a conical structure, 32 radial main beams, 3 ring beams, 96 steel cladding panels, and 3 steel platforms.
It's massive.
41 meters in diameter, 11 meters high. Total lifting weight of nearly 1,000 tons. But I'm honestly wondering, why is hoisting a metal roof the milestone we care about? Isn't pouring millions of tons of foundation concrete a bigger deal?
I mean, the concrete is a huge deal, but what's fascinating here is that hoisting the dome is the great physical demarcation line of a nuclear project.
Okay, how so?
Well, the brief notes this transitions Lianjiang Unit 1, which, by the way, is a CAP-1000 reactor expected to operate in 2028. It transitions it from civil construction to equipment installation.
Ah.
Think of the civil phase as heavy, messy outdoor work, rebar, pouring concrete, fighting the weather. But once you hoist that dome and weld it into place, the building is sealed.
So it becomes like a clean room.
Basically, yeah. You're now in a controlled environment where teams can begin the surgical work of installing highly pressurized pipes, the reactor vessel, all the delicate control systems.
Oh, wow. That makes total sense. So it shifts from a construction site to a high-tech installation environment.
Exactly.
But then we look at another site, Xudapu Unit 3 in Liaoning Province. This is a VVER 1200 reactor, and the brief states they just completed hot functional testing.
Right, which is a critical milestone ahead of fuel loading.
But that sounds like intense engineering jargon.
Yeah.
What does hot functional testing actually look like in the real world?
It's actually a really fascinating piece of physics. So before a reactor is ever loaded with radioactive fuel, you have to prove that the whole labyrinth of pipes and valves can handle extreme pressure and heat.
Right.
So they fill the primary cooling system with regular water, and they turn on the massive coolant pumps. And they run those pumps so incredibly hard that the sheer physical friction of the water moving through the pipes heats the water up to its actual operating temperature.
Wait, really? They achieve operating heat just from the friction of the pumps?
Yes, hundreds of degrees. They simulate the exact thermal and pressure conditions of a live nuclear reaction, but without any nuclear material at all.
That is wild.
Yeah, and completing this test proves the integrity of the system. Xudapu Unit 3 is expected to be commissioned in 2027, and passing this test is basically the ultimate proof of concept.
Okay, so while one plant is doing that extreme friction testing, we have 2 other sites making progress on their containments. At Taishan Unit 3, they installed an inner steel containment section.
And that unit is expected to finish around 2030.
Right. Meanwhile, at Lufeng Unit 1, they installed the second ring of their steel containment. And I think this proves your point about the supply chain.
Oh, absolutely.
You've got these completely different phases of construction happening simultaneously across completely different sites.
And that is only possible because of the batch approval pipeline. The conveyor belt is just fully operational.
But here is where it gets really interesting to me. I'm looking at the reactor types listed in these updates, and it is a complete alphabet soup.
It really is.
Like Lianjiang is a CAP-1000. Xudapu is a VVER 1200. Taipingling is a Hualong one. They're definitely not just stamping out one single standardized blueprint for all 39 units.
No, they're not. And that's a critical observation. The major operators running these projects, CNNC, CGN, SPIC, they are deploying a highly diversified technology portfolio.
Which seems counterintuitive if you're trying to build fast, right?
Well, let's look at what they have. They're heavily utilizing the Hualong one, also known as the HPR 1000.
Right.
We see that deployed at Taipingling, Zhangzhou, Shidawan Phase I, Jinkamen, and Fangchenggang. That design is very much their domestic workhorse for this batch scale expansion.
But then you have the CAP 1000 pressurized water reactors at Haiyang, Sanmen, Lufeng, and Beilong. Plus, there's explicit international cooperation going on.
Exactly. The VDER 1200 at Xudapu is supplied by Russia's Rosatom. And at Taishan, they're operating EPR units deployed with France's EDF.
So why diversify so heavily? I mean, doesn't introducing 5 different blueprints slow down that airplane manufacturing model we were just talking about?
It does introduce complexity, sure, but it is a calculated risk mitigation strategy. By deploying multiple proven Generation III designs, they are ensuring that a hypothetical supply chain bottleneck in one design doesn't bring the entire national pipeline to a halt.
Oh, so if one design has an engineering quirk, the others keep rolling.
Exactly. It also allows them to absorb operational data from French, Russian, and domestic engineering philosophies all at the same time.
And it seems like they're using that base load of proven technology to afford themselves the luxury of beta testing the future, because the brief outlines some highly advanced niche tech as well.
Yes, the portfolio extends way beyond standard pressurized water reactors.
Yeah, the brief highlights the Xiapu site, which houses the CFR 600. That's a sodium-cooled fast reactor. Now, the document notes Unit 1 has been in extended test operation since late 2023, and it states that full commercial power output targeting 600 megawatts net is expected imminently.
But we should be precise here.
Yes, I want to be very precise. The brief explicitly marks this commercial output as unverified.
Which is such an important distinction when reading institutional intelligence. We only bank on what can be verified. But, a fast reactor is an incredibly complex leap.
How does it work?
Instead of using water to cool the core and slow down neutrons, it uses liquid sodium. This allows the neutrons to move much faster, which can theoretically utilize uranium fuel much more efficiently.
Oh, wow.
But it's incredibly difficult to commercialize, which makes the site one to watch closely.
For sure. But they do have verified advanced tech already operating, right?
Right.
At the Xudapu 1 site, the HDRPM, which is a high-temperature, gas-cooled reactor that entered commercial operation back in December 2023.
Yes, it did.
And then there's the Fangchenggang site in Haiyang province. This one really caught my eye. It hosts the ACP-100, which the brief also calls the Linglong 1.
The SMR.
Right, a 125-megawatt small modular reactor. The brief says it's pending hot functional tests and fuel loading. What is the strategic value of building a 125-megawatt SMR when you are simultaneously building massive 1,200-megawatt behemoths?
It's all about geographic and grid flexibility. A 1,200-megawatt plant requires massive grid infrastructure and an enormous cooling water source. You can't just put one anywhere.
Right.
A small modular reactor, though, is designed to be largely factory assembled. It can be deployed to industrial parks, remote regions, or islands that just have smaller power grids.
Oh, I see.
So testing the Linglong 1 in a commercial environment while the massive plants provide the national baseload, it's a textbook example of testing next-generation tech without jeopardizing your core energy targets.
Okay, so we've covered the macro policy, the week's physical construction milestones, the diversity of the reactor portfolio, but eventually, all of these domes and tests have to result in actual electrons hitting the grid.
Right, because that's the ultimate metric of success, power generation.
Exactly. And the brief details several commercial rollouts that happened in the spring of 2026. Let's look at Zhangzhou in Fujian province.
Okay.
Unit 1 has been commercial since January 2025, but Unit 2 entered commercial operation precisely on January 1st, 2026.
Starting the year off strong.
Yeah. And the commissioning timeline for Taipingling Unit 1 gives us a perfect window into the final steps of this process. The brief lays out the exact sequence.
Let's hear it.
It achieved first criticality on February 3, connected to the grid on February 13th, and entered full commercial operation on April 19th, 2026. Unit 2, right beside it, has already completed fuel loading and expects commercial operation in the second half of 2026.
It's a very methodical handover.
It is. But let's unpack that term, first criticality. It sounds very dramatic. What exactly happened on February 3 at Taipingling?
Well, first criticality is basically the moment a nuclear reactor truly comes alive.
Okay.
After all the hot functional testing is done and the uranium fuel assemblies are loaded into the core, the operators slowly withdraw the control rods. First criticality is the exact moment when the nuclear chain reaction becomes completely self-sustaining.
Oh, wow. So it's finally running on its own.
Exactly. The reactor is generating a steady, controlled amount of heat on its own for the first time. And then 10 days later, they connect to the grid, and 2 months after that, they are officially deemed in commercial operation.
Yep.
Now, we saw another one of these commercial handovers at the Sanmen site. Unit 1 entered commercial operation on April 29, 2026. But here's where it gets really interesting. The brief specifically calls out a financial detail about this project.
Ah, the private equity stake.
Yes, the brief notes that Sanmen is notable for explicit private equity participation. Specifically, GWe Technology Group holds a 2% stake.
Now, GWe is a massive automotive and tech group, and nuclear infrastructure is traditionally, heavily state-driven. You have state-backed giant doing the heavy lifting. So why would the state allow private equity into a multi-billion yuan project? And why is a 2% stake significant enough to make it into this intelligence brief?
It's a brilliant detail to pull out, honestly, because it points to the evolution of their financial model. Look at the numbers. A single site like Taipingling, which is planned for 6 units, represents an investment exceeding 120 billion yuan.
Which is massive.
Yeah, if the national target is to reach 110 gigawatts by 2030, the capital requirements are just astronomical. The heavy lifting is absolutely still done by the state, but allowing a 2% private equity stake, that tests a new mechanism for raising capital.
Oh, so it's a proof of concept for diversified funding.
Exactly. And from the perspective of an automotive tech group like GWe, securing an equity stake in a nuclear plant could be about securing reliable baseload power for future EV infrastructure or heavy manufacturing.
That makes total sense. It signals that the financial mechanics are evolving right alongside the engineering.
Absolutely.
And, the pipeline just keeps moving. Back at the Fangchenggang plant, the brief notes that Unit 3 began its first fuel loading on April 30, 2026.
Right, pushing it into the nuclear commissioning phase.
Yep, setting it up to be the next unit to hit criticality. So if you're listening and wondering how this actually shifts the needle on global energy markets, let's just summarize the sheer density of what we've unpacked from this mid-June 2026 briefing.
It's a lot to take in.
It is. We are looking at an infrastructure program systematically executing a master plan, targeting 110 gigawatts by 2030, 39 units actively under construction simultaneously,
The hot functional testing clearing the way for fuel loading.
a highly diversified technology portfolio, scaling pressurized water reactors while simultaneously testing next-generation fast reactors and SMRs, and multiple massive units crossing the finish line into commercial operation in just the first half of 2026.
It's just the relentless unit-by-unit execution of a macro strategy. And, that actually brings me to a final thought I want to leave you with, drawing directly from the long-term aspirations cited in the document.
Yeah, what stands out to you?
Well, the brief notes that widely cited policy aspiration to reach 200 gigawatts by 2035. That would shift nuclear power from roughly 4.5% of the nation's total power generation today up to approximately 10%.
Right.
If they successfully execute that long-term vision, what does that scale of reliable, non-intermittent baseload power mean for the industrial dynamics of the world's second-largest economy?
That's a huge question.
It is. Because if they can standardize this unprecedented pace of construction, if 4 consecutive years of 10 or more reactor approvals becomes the new normal, it really forces us to ask how that might entirely redefine global energy expectations over the next decade.
Wow. From a 1,000-ton steel dome to 200 gigawatts. Definitely something for you to think about the next time you watch the concrete dry.